As you come in, let me know if you have questions from homework, if you have questions from the midterm, if you have questions about the grades that I've posted. I took over. I stopped letting Canvas calculate the average because now we have a midterm in there that's more heavily weighted. So I had to take over. I manually input 3 different grades averages for you. So let me make sure that makes sense. If you look in grades, towards the bottom, you'll see average, not including homework average, no homework average, all homework goods, blah, 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 blah. Let me know if that does not make sense. Let me know. So any questions from anything?
I have a homework question.
Yes.
For 6.1, number 21, I'm like kind of confused about it. Like I got an answer, but I don't think it's right.
All right, hold on. So number 21, this one?
Mm-hmm. Yeah.
So how did you get your answer?
So I was looking for X, and I did 8 plus 9 times 0.67, and then I got 14.03. But I think I'm doing it wrong.
All right, hold on. Sorry, I had a technical difficulty. There we go. Dadgummit. So I'm sorry. You're gonna have to say this again. Okay. So all right. Let me put this up here. Actually, this is a very useful formula. You're gonna have to use it in a few different places.
Yeah, so I used that formula.
Good.
So I did 8 plus 9 times 0.67.
Okay, you'd made one mistake. This would be if I wanted to go up, if I wanted to go to the right, 0.67, but it says to the left.
So would it be negative?
Yes.
Oh, okay. Thank you. That helps me a lot.
Yes, it does. Okay. All right, good stuff.
I have a question. For number 12, I was a little confused on how to exactly do it. I checked the chapter and I just couldn't figure it out.
It's the way they word this. Now watch this. So number 12 is not a formula problem. It's none of that shit. It's a conceptual problem. What does the z-score tell you?
How many standard deviations one is away from the mean?
Good. So doesn't it tell you that directly? Number 12, doesn't it just tell you that? Do you see what I'm saying?
Yeah.
It's 1.5 standard deviations to the left of the mean. So that is the z-score. There's no work to do. You just have to know what it means to be to the left. So is it 1.5?
No, it's negative 1.5.
Done. Yay. So that's a conceptual question. Yeah.
Oh, thank you.
Sure. And again, don't feel bad about that. It's not easy to tell what's just a conceptual question, what's the problem that requires work. But this one's more like, do you know the definition of z-score? And then it's just, is it positive or negative? Yeah. All right. How's everybody else? Somebody else had a...
Can you go through number 36? On 6.1.
Ooh, yeah. This is good. So, all right. This is kind of bad too. This is very poorly written. What they should say is, they should word this differently. So the way I normally say this is 2 values are equally spaced on either side of the mean. That's the way they should say this. So so I got a normal curve. The mean is -3. The standard deviation is 1. Between what 2 x values is there 34.1% of the 34.14 of the data. All right, now this one's a damn good problem. I want to do this on the board actually, because this one gets really into it. So let me do this up on the board, which means I got to turn off my. Hold on, let me turn off my Mars. Hold on, there we go. Bam. All right, Oh shit, where am I gonna put this? Okay. All right, so wow, Jeff, that's a little close. Get up. Get back. Get back. First off, well, let's see. All right. I say this. If I wanted to know, so they tell me that the mean is -3. They tell me your standard deviation is 1. If I wanted to know, let me ask you a different question. This is Jeff's question, not the book's question. If I wanted to know what's the, you can do it, Jeff. Yeah, what's the X score that has 0.1587 below it? I want to know the X score. So this is a normal distribution. I want to know the X that has 0.1587 below it. Okay, this is good because there's quite a few problems that say exactly this or something related to this. I'm given a percentage, 15.87%.
-1.0.
Let me write that a little bit bigger. No, wait a minute. Sorry?
-1.0.
That's the what now? That's not the X, that's the what?
That's the z-score.
That's the z-score. I like it. Now, does everybody see how she got -1.0? Or does anyone not see? If you don't, let me know. By the way, I said not see, not Nazi. So be careful. It's fine. You don't have to say I'm not a Nazi. No. Everybody's good. Everybody sees that. If you look up 0.1587 on the z-score chart, you'll find 0.1587, and it's right next to -1.00. Right. So that's the z-score that has that much below it. So then, how do I find the raw score? Well, I use that formula. And I plug stuff in, -3 plus z, well, z is -1, so -1 times the standard deviation. Jeff, the standard deviation is 1. There you go, buddy. So then I get -4. Okay, let me stop. So you have to let me know. Wow. New marker? Damn. All right, sorry. I'm going to get a little high. You have to let me know if this did not make sense. They gave me a percentage. What can I do with a percentage? I can look it up on the z-score chart, but that's not what they want. They want a raw score, so I've got to use this formula to convert it back to a raw score. So how does this relate to the problem that they actually gave us, right? This is nice, Jeff, but this is not the problem they asked. Okay, I'm going to erase this. So the actual problem they ask is what raw scores have 0.3414? Is that what it was? Yeah. Same problem, normal, mean is -3, sigma is 1. They want to know what these raw scores are here. So what do I have to find first? If I wanted to know this guy, what would I have to find first?
The negative z-score.
Yeah, the z-score. I like it. Now, does the chart understand this area at all? Does the chart understand the area between things? What's the only area the chart understands?
Left or right?
No, stop. It only understands the area left, below, right? So if I want to know this z-score, I can find it if I knew this area. Does that make sense? How the shit do I find this area? Well, if there's 3414 in here, how much is out here? Let me know the minute I lose you. If I lost you after I wrote these down, all right, you've waited too long to speak up. You have to let me, the minute I lose you, you have to let me know.
Would it be 1 minus 0.3414?
Exactly. So that would be, that's the area outside, right? It's not the area here yet, but it's the area outside. So that would be 0.6586. So how do I get the area that's just on this side?
Divide it by 2.
Divided by 2. Kick ass, which is, I don't know, 0.3. You guys gonna let me do this by myself?
Me.
Who is it?
You lost me at the point. Yeah.
Okay. Make sure. All right. Let me stop. Let me go to right here. This is what they're asking in the question. Let me make sure I'm looking. This is number 36, right? Let me make sure I'm looking at the right one. 36. All right. Now, this is what they're asking in the question. They should have done a better job of saying they were on either side of the mean. That's the only way you could really do this problem. Okay. So is everybody cool with the picture I've drawn from the problem? Okay. If there's 34.14% in here, what percentage is not in there? It's outside. What's the total percentage outside? Right? If 34.14% are in the house, what percentage are out of the house?
0.6586.
Yeah, 1 minus that. Is that cool? Does this step make sense? And again, why can't I just look up this number on the z-score chart? Because the z-score chart only understands areas below something. All right, so I really want, so I need to figure out these two X scores. So I'm going to use this formula twice. I can't use that formula once until I know the z-score. So I need to figure out the z-score for both of these. So how do I figure out the z-score for this guy? If I only knew this area, I could look it up because that's exactly what the chart is for. Give me a z-score, I'll give you the area below it. Give me the area below something, I'll give you the z-score. It goes both ways. All right, so that's why I want to figure out the area outside. So then I can figure out the area on this side. And again, let me know if that doesn't make sense. It's okay. It's still relatively brand new. Is that okay, everybody? What's up? Okay. All right. And again, it's okay if the answer is no. All right. So this was 0.6586. Is that what it was?
Yes.
Yeah, 6.86. So that's outside. But I want the area just on this side, so then I can look it up in the chart and get that z-score. So then I can do this and get that x-score.
So you're gonna divide it by 2.
Yeah,
then,
divide it by 2. I like it.
And you get 0.3293.
Sounds about right. So now I know this area here, 3293. And if you look that up in the z-score, and again, you have to look it up in the body, 0.3293, and then you can see what the z-score is by looking out. This is not a z-score. Don't make this 0.33 and look it up. It's not a z-score, right? I need to find the z-score. Oh, I see. They do say it in 34 and 35, but not that. All right. So let me know. If you look up 0.3293, can you guys find out what that z-score is? Let's take a look at the z-score chart. Hold on. Shit. Where are you? Shit. Oh, here it is. Okay. So 0.3293. I know it's going to be negative because it's below the mean. Right? And sure enough, 0.3293.
Would it be negative 0.44?
Yeah, it looks like negative 0.44 is the closest I can get. Do you guys see that? 3293. The closest I can get is 3300. That's negative 0.44. So again, another way to look at that is, I really want this to make sense. What value, what z-score has 50% below it? You should all know this. What value, what z-score has half of it below it? You should know that. Damn.
0.
0. I love it. So really what I'm saying is, all right, how far down from 0 do I have to go until there's 0.3293 out there? And that's what the chart does for me. It says, oh, if you just go down, shit, you should have wrote it down, Jeff, negative 0.44. If you go down 0.44 standard deviations, you will have that about this much area out there. I really want that to make sense because this is 50. So I've got to go down a little bit. So now it's 32.93 instead of 50, right? Got to go down a little bit. So it's 32.93. What must this one be then? What does it have to be? What's the z-score for this one? Positive 0.44, kick ass. So now you just have to use this formula twice. Throw that in there with the mean and the standard deviation, bam, and then throw positive 0.44 in there with the mean and the standard deviation, bam.
Do we do both the negative and the positive?
Yeah, because it says what two values. So I have to have the one side and the other side. It's like bookends. So this one contains this much percentage. If I just do one side, it's uncontained. It's just going to go forever. It's no good. I need containment. Right? If you look at the thing, it says what two x values, right? I believe. It just says between what x values. So you have to get 2. Yep. So that's a pretty good problem. In general, can I erase this? Have you guys got what you need from this? Yes, okay. If I ask you, if I give you if I say I've got a normal curve and I ask you a probability question about something, right? You've got to look up a z-score and then get a percentage, right? So I've got to first, let me see, let me get this all written down. You got to make this into a z-score. Then you can look it up in the chart to get a percentage. If I give you a percentage, like a percentile, or like this problem just did, it gave us this percent, and I want to find something, I've got to first look up in the chart to get a z-score, and then I can use that to get a raw score. So it's the exact opposite of this. So this way I start with the raw score, make it a z-score, look it up to get a percentage. Here I start with a percentage, I look up the z-score, and I convert that back to a x-score. Holy shit. All right. So it's kind of nice. I mean, math, a lot of math is able to go both ways, right? Be jealous. So I can make an x become a z, become a percentage, or I can go backwards. I can make a percentage become a z, become a raw score. So watch this. Let me ask you this very direct question. If I had a normal curve, it doesn't even matter if it's normal, to be honest, but let's say I have a normal curve, the mean is 5, and the standard deviation is 2.5. Can you figure out what score is what X score, oh my gosh, Jeff, is 1.2 standard deviations above the mean. This should sound a lot like the homework. What X score is 1.2 standard deviations above the mean?
Would it be 8?
How'd you get there?
Well, I did an equation. I put 1.2 equals x minus 5 divided by 2.5.
Oh, okay. So you use this thing, but I really, really want you guys, isn't this, this is the same formula. It's just more useful for this situation. This is the same formula. It's just, this formula is better to use if I know these three, and this formula is better to use if I know these three. And what do I know in this case? I know the mean, I know the z-score, and I know the standard deviation. So we'll get the same answer. I'll just get it faster because I'm good at this shit. No, but you, I'm sorry, don't take that wrong. It's just that they're both the same formula, who cares? But one's just a little bit quicker for this specific situation. Is everybody cool with that? Why does this make all the sense in the world? Because how do I get to this? Don't I start at 5 and don't I go up 1.2 steps? Isn't that exactly what the hell this thing says? Start at 5, go up 1.2 of these. That's what the formula says to do. That's what the shit I would do. I wouldn't even need the formula to do that. Right? The formula is kind of nice to have and look at. So whatever that is, I almost don't care what that is. What is it though? What would that be?
15.5.
Is that right? That seems high. Or am I just high? I could be just high. That's a little high. It makes more sense to be 8, right? Is that what you said? You get 8?
Yeah, it's 8.
8. Okay, that makes more sense because it's 5 plus 3, so that'll give you 8. What did you do? I wonder. Did you add first and then multiply? I think it's what you did. Maybe.
Yeah, I did
Okay.
that.
You gotta be careful. Some pesky order operations. Please excuse my dumbass son. You gotta be careful. Or do your own self. Whatever way you like better. All right. Now, what does this have to do with shit, Jeff? All right, so what if I were to ask you a completely unrelated, not really question? Can you tell me if I have a mean of 5 and a standard deviation of 2.5, what score has 11.5% above it? What raw score has 11.5% above it? So now what do you have to do? Why was this easy? Because I knew the z-score. It just tells me the freaking z-score. What does this thing do? Shit, it gives me a freaking area. God damn it. If they would have just given me the z-score, well, can you figure out the z-score? Can I look up 0.115 and get the z-score from that? Not really. What do I have to look up? What's the chart understand? Where am I at? Yeah, 1 minus this, right? And what's 1 minus this? Oh, did I do this right in my head? Yes, I did. Okay, good. Sorry, I'm trying to lead us down a certain road here. Is everybody with me? What's the only area the chart understands? Area below. That's an area above. Well, damn it. All right, I'll make it an area below. So what's the area below? That's right, kids, 0.885. Can you look that up and get the z-score? Because we see how easy it is. If I know the z-score, it's easy. Here, they didn't give me a z-score. They gave me an area. Damn you. So I got to first do this, and then I got to look it up. Can anybody find that? Yeah. the closest area should be 8849. That's pretty much exactly 1.2. And then what do? I do exactly what the shit we did over there, right? So telling me an area adds one step. I'm like, oh man, why didn't you just give me the z-score? Okay, let me go there. I'll look up the z-score. Now I would do exactly what we did there. Because now I know the z-score is 1.2. I can change it back into an x. So really all this is saying, I really want this to make sense. The mean cuts it in half. How far up do I have to go until there's 88.5% below where I am? So I know it's got to be more than the mean. I'm just wondering, how many steps do I have to go? Well, now I know it's 1.2 steps. If I go 1.2 steps up. All right, so how do I find out where I am? Well, I take 5 and I take 1.2 steps up. That's how I do it. I just feel like you're not all quite with me, but I really wish you could see how physically this is very simple. It's, and you're like, that doesn't help, Jeff, I know. But the whole idea about what percentage do you want where directly relates to how many steps you take up or down. That's the whole thing with the chart. What does the chart do? What area do you want somewhere? Okay, that translates into how far you've got to go. How far do you have to go? Once I know how far I have to go until I have a certain percentage somewhere, then I just go that far. Mean, go that far, where each step is this big. Okay, I don't know, maybe. I have no idea if that helped anybody. This is why statistics is generally thought of as more difficult, is because you can't divorce the concept from the formula. They have to work together. You have to understand the idea to use the formulas correctly. In a lot of algebra, you can sort of like not have a clue what you're doing, but still plug shit in and get something. Right? And I will admit that happens. But statistics, you're not going to use the formula correctly if you don't even understand the idea behind it. All right.
Wait, so for the question or problem that we just did,
yeah,
would the answer to that question be 0.885 above it, or because
what's up? Sorry. Oh, so the 0.885 was the area below that led us to this z-score, right?
Yes.
Now the answer is going to be 8, because now we're at the same place we were here. This problem, I told you I was 1.2 steps up. Right? I really want you guys to see. Here I just told you you're 1.2 steps up. Okay, so I'll start at the mean and I'll go 1.2 steps up, where every step is that big. This problem, I didn't tell you where you were. I told you what area there was supposed to be there. So then I'm like, well, shit. I got to figure out how far I've got to go. Here I told you how far to go. Here I didn't tell you how far to go. I just told you what area I wanted there to be here. So like, damn it. All right, so the area on this side, because that's what the chart understands. When I looked that up, I got 1.2. Now I can do the formula. That's what I mean. The answer is going to be 8 again, because it's going to be the same work. It's the mean, go up 1.2 of these. So it's still 8. So in a sense, these are the same problem. This was easier because I gave you the z-score. So you knew you had to go 1.2 steps. Here, I gave you what area I wanted. You're like, damn it. Why didn't you tell me how many steps? Oh, shit. Well, okay, so I'll figure out how many steps I've got to go. Let's do another problem. All right. I really want you guys to get this. All right. I really, you guys I probably erased that too fast. I'm sorry. Here. Normal curve. Mean is 10, standard deviation is 2. Can somebody tell me if I go down 1.72 standard deviations, where do I end up? Start at 10 and I go down 1.72 standard deviations. What score will I end up at? Okay, this is, you don't even need, so every step I take is how big? 2. I want to go 1.72 of those down from 10. I don't even need a formula, right? But it's nice the formula is there. How would I get there? What would I do? I would start at 10. I would go down, so I would subtract 1.72 of these. That is mean plus z sigma. And some of you guys are like, well, why is that minus? Because the z score would be negative here, right? Because I'm going down. Let me stop for a minute. You guys okay with that? Why is that a z score? Because the z score is the number of standard deviations away from the mean. That's exactly what 1.72 is. It's the number of standard deviations away from the mean. That's why that's the z score. Why is it negative? Because I'm going down. So again, the formula is nice, but it's actually more than I need. It just makes sense. Start here, go down this many of these. Start here, go down this many of these. That's all that means. So it goes right along with the main idea of z-scores. Now, and then you get whatever, I don't almost care about this, but I think it's 6.56. Is that right?
That's what I got.
Okay, cool brain. My brain is working. Now, what do you guys think? What's a different way to ask this question? All right, let me see if you guys can make this question. Can somebody figure out what area there is here? If the z-score is negative 1.72, right? So let me put this in here like this. I always put z-scores in little parentheses and raw scores not in parentheses. It's just something I do. You might want to do the same thing. Can somebody figure out what the area is here?
Would it be 0.0656?
No. Let me see, unless I'm looking at this cross-eyed. 0.656, where'd that come from?
I don't know. I was just guessing because I saw the number at the end, like how we just worked out the
Oh,
equation.
no, be careful. This has nothing to do with z-scores. It's like there's a z-score, but there's the mean. Yeah, be careful. This makes sense because it's less than 10. That's why it's below here, but it has nothing to do with the area, right? So how would you figure out the area? Do you have a magical chart that converts z-scores to areas below? Did your teacher give you that? Oh, that seems like a nice thing to have. So
It's 0.0427.
let me see. 0.0427, right? I like it. So how can you reword this problem where you don't give the person this? You don't give them this. You would say, what raw score has 4.27% below it? Do you guys see that? Wouldn't that lead to the same answer? Wouldn't it lead to the same answer? Because it would lead to this z-score, which would lead to this answer. So if I give you the z-score, that's great. But give me the z-score, Jeff. I'm not always going to do that. Nah. I'm going to give you an area, which you then convert into a z-score, which you can then convert into a raw score. So why does this make sense that this area converts into a z-score? Because again, what's below 10? 50%, right? Mean cuts it in half. So that's 50% below there. So I have to go down so many steps until there's only less than 5%, right? How many steps do I have to go down? Well, we figure out it's actually negative 1.72 steps. The z-score chart, you can look at it like this. This is a beautiful way to look at it. It tells you how many steps until you're left with this percentage below. If it's negative, you have to take steps down. If it's positive, you have to take steps up. That's it, right? And then you got this formula to convert the z-score back into a raw score. Okay. Maybe? No, not really. No help. Screw you, Jeff. You suck. Okay. I just desperately want you guys to get this idea. It's kind of, I know, it's so weird when I say it's beautiful, but the mean cuts it in half. So this is 50% and that's 50%. So if I wanted to go until I had 10% up here, wouldn't I have to take a few steps to get to that point? So there's only 10% here. Do you guys see how that works? So the mean is at 0. So how many steps would I have to take until I've got 10% left above me? So I take some steps. How many steps is that? Well, it's not a formula I can use. It's the z-score chart, right? So if I have 10% above me, how much do I have below me?
Point
90.
90.
0.9. And what do you guys get when you look up 0.90? And you know it's going to be in the positive side, right? Because we're above the mean. So what do you guys get when you look up 0.90? Let's see. Oh yeah, it should be something really, really, really close.
$1.18.
No. Oh, I think you just got cross-eyed a little bit. It's 1.28. So if I take 1.28 steps up, then I've left 90% behind me. I've only got 10% ahead of me. That is why the z-score chart can exist, because as I move, which is z-scores. Z-scores are me stepping around. Then the amount of area that's on one side or the other of me changes. The z-score chart captures that connection. So that's why if I know how much percentage I want somewhere, I can convert that into a number of steps to go. Okay, all right. All right. Anything else that you want me to overanalyze?
So, probably making it worse. What do you do then when it's asking you for less or greater than?
What do you mean? Like what?
Like, I'm looking at the homework, like problem 51. It says a probability that X is less than 30 with.
It sounds like a classic z-score problem. So the ones we're doing up here are more backwards problems where they give us the percentage. Which problem are you looking at?
51.
51, okay. I love it. This is what I call a classic z-score problem. They gave us, what's the mean in this problem?
54.
Good. So the mean is 54. The standard deviation is 8. They tell me it's normal. That's what the n means, right? B is binomial, U is uniform, n is normal. And together they make the force of Bunn. Okay. So here we go. I've got my normal curve. No, Jeff. The mean is 54. Scheisse. Okay. And they want to know the probability X is less than 30. Where's 30?
To the left.
Good, right? It's got to be this way. The thing that drives me crazy is when people just throw 30 wherever they want to. That's kind of insane. 30 is below 54. So they want to know the probability, and where am I going to shade? Where's the area that matches the question? Which side do I shade?
The left.
Down here, I like. So now I just have to make 30 into a z-score, and then I can look it up, and then I'm done.
Oh, okay.
So this is what happens. That's where we started, right? Those kind of problems were our bread and butter. But then we started looking at the reverse problems, right? The backwards problems where they give us the percentage that we want, and they're like, well, what raw score would lead to that percentage? So then when you go back to this kind of problem, you're like, holy shit. So it's just sort of like grinding your gears when you're and you don't know how to drive a stick shift. You know. All right. So this is our standard. So you make a z-score out of the data point, right? X minus the mean divided by the standard deviation. You make that z-score, you look it up. Why am I going to be done when I look up that z-score? Because the chart gives you areas that are below. That's why I'm going to be done. I don't have to adjust it. I don't have to do 1 minus it, any of that kind of stuff. Some of you guys go a little 1 minus happy. You want every problem to be 1 minus. I don't know if you're doing that just to sort of hedge your bets. You're like, I've got to be right sometime. But you're going to be wrong more often than right. A little bit. All right. Does that make more sense? That is a standard z-score problem. That's the kind of z-score problem that we started with, right?
Yes, thank you.
Is that a Pez dispenser? Is that what it is? Anyway, sorry. What's up?
I have an overall question.
Sure.
So this homework assignment 6.1, I'm pretty sure now that I've seen everybody ask questions about different problems. So when you say numbers 12 to 30 and every third one, is
Yes.
that number 30 to 63? Or is it every third one in between 12 and 30?
All right, let's look at the homework.
Because I'm so confused now.
Hold on. People can ask me any question from homework they want to. And I mean, even if it's not something I assigned, but let's see what the actual assignment is. 12 through 30, every third one is 12, 15, 18, blah, blah, blah.
Okay. So we didn't have to do.
Sorry?
Okay, never mind. I see it. Never mind.
Yeah,
I see where
yeah.
they're asking it from now.
Okay. Like, but this is the only time I do this. And normally I do my entire homework using every third one, every fifth one. But with this weird ass book, I couldn't do that. But this one little section, I could do this. So 12, 15, 18, 21, 24, 27, 30. And then you do 63, 64, 67. Yeah.
Oh my God, it wasn't 33, 63.
No, then I would have said, because here I say 12 through 30, every third one. All right. But, you got more practice. What's wrong with that? Shit. We got a midterm happening. I'm sorry, that just happened, but we got a quiz coming up. That's what I want to say. April 12th. Any what do you want to say? Practice you get is better, right? What the heck? Okay. And you're all like, no, that's just life wasted, Jeff. I'm like, all right, I'm sorry. These things happen. Okay. Anything else, guys, before we get back into where we left off?
Would you be able to go over a question from the midterm?
Yes.
Okay. On my version, number 2 was the randomly select 6 grades.
Oh yeah, everybody had that.
Kind of started off wrong because you marked out my first 2 categories that I had filled in. I'm not sure where I went wrong there.
Oh, hold on. Who's talking to me? Say something.
Oh, Angeline, sorry.
Oh, there you are. Okay. Okay, so real quick, let's see. Oh, good. Thank God. Oh, okay. So a few people did this. Okay, I love you guys. I love you guys so much. Number 2, there are no probabilities in number 2. So you guys were trying to force it to become an XP of X thing.
Oh.
No. So it's the stuff from 2.7. It's if you look at your formula sheet on the last page, see how I have 2 problems circled and I say number 2?
Yeah, I saw that. So use
So
that.
that's the formula you've got to use for number 2. So X minus X bar, and then you square them and you add them, divide by n minus 1 because it's a sample. Yeah.
And then that's for each row then? Are you using that formula for each row?
Definitely not. You can't sum up stuff that you don't have a bunch of. So what's in the column is X minus X bar and X minus X bar squared.
Okay.
So what goes on top of the formula for S is the sum of x minus x bar squared. All right, so let me show you this.
That makes way more sense.
So when you go to do your corrections, you can actually go back to, this does not just apply to you, trust me. Quite a few people did the exact same thing. Don't worry, I'm not, here, standard deviations. Go back to this bad boy. Load. Okay, there. Remember this stuff?
Oh, okay. I'm gonna go back and find that.
Okay. Cool.
That's probably all I needed. Thank you.
Sure. Yeah, so you can definitely still make corrections to your midterm, and you definitely want to do that because your midterm is pretty heavily weighted, right? So any points you get back on the midterm will affect your overall grade much more than correcting any quiz or homework assignment. So you definitely want to make corrections to the midterm for sure. All right, guys, anything else? All right, let's do this. I like this because this sort of builds into what I want to do first. If you go onto Canvas right now, let me make sure I've got this active. I think I do. Yes, no. Where'd I put it? There it is. Okay. If you go into Canvas right now, let me show you. There's something called even more normal distribution practice. Let me show you where it is. Oh, real quick. While I'm thinking about this, I really just want to, if you go for tutoring in the Math Study Center, I can see everybody that goes for tutoring. I can see a list of my students who go for tutoring. And guess what I do at the end of the semester? If you're really close to like, if you got a B minus, but you're really close to having a pure B, or if you have a B plus and it's really close to an A minus and you went for tutoring, I might push you up, right? So it's a little extra credit at the end. Do you understand what I'm saying? So there is, you should just go to tutoring just because it will help you. But there's a little extra bonus from me at the end because I can see, like I said, I get a complete list of who went for tutoring and how much. So then if you're really close to something, like you got a 69.4, this might happen. I don't know. This might be a little too, and you went for a lot of tutoring, I might push you over the edge. You might pass. Holy shit. Okay. Something to think about. So I don't like give you a ton of points. That would be insane, but I do bring it in at the end. I do consider it. So even if, anyway. So if you scroll down to unit 6, see this even more normal distribution practice? All right, let's do this here. I'll say let's, and it's really you. So pull this bad boy up and work on it, and then we'll do it together here in a bit. And then we'll get into chapter 7. This is about rents in Waikato, New Zealand versus San Diego. Yes, I was considering moving to New Zealand. Of course, I've been considering moving outside of the US for a while now, but we'll see. You never know. Can everybody access that on your own? If I stop sharing, is everybody going to freak out? Can you guys get that? Okay, thank you. All right, hopefully everybody else is still out there. It's just me and Leilani now that I can see. All right. All right, so this is a classic z-score problem, right? They give me a bunch of raw scores. I got to convert them to z-scores, and then I could look up the percentage. I just want to say that's some of the neatest writing I've done in a long time, which is kind of sad, but that's okay. I can do it. Dadgummit. Close my my calculator. No, I don't want tips. Go away. Okay. So these are exactly the kind of problems that I really enjoy asking on a quiz or a final exam or something. I don't know. So let me ask you guys something. Can you guys, you probably already did the z-score, but if a full step, now just think about this for a second. If a full step is 136.91, right? Is 930 even a full step down from the mean? Every step is 136.91, correct? So
No.
yeah, 930 is like a very, so I would say 930 is very close to 966.84 because a full step is 136. That would take me down to 830. Do you guys kind of follow what I'm saying? So why am I saying this? Because if you plug this in the calculator wrong, you'll get an answer like 922. And what somebody did to get that answer is you didn't tell the poor calculator that that's the top, right? Calculator understands order operations. It would divide first unless you tell it, oh shit, calculator, you don't have eyeballs. I'm sorry. This whole thing is on the top. You guys follow? I've seen a few people doing that. Just take a second and make sure it makes sense. Don't just write that shit down because that's what you got. You're the human. Make sure it makes sense. Anybody get this other z-score yet?
I got 1.7.
Yeah. I like it because it's like 03, so you just 1.7. I like it. And now we're in the situation where this area is too much. So then I'm going to subtract off this area. So I just have to look up those two z-scores, right? Does this feel familiar? We've done several problems like this. So if you just look those up on the chart. Yeah, I guess I could do that. Where they are. Shit. R. No idea. All right. So what do you guys get when you look up the, what was it? Negative 0.27. What do you get for the area?
Point
0.3936.
I like it. 3936. So this is 0.3936 there. Man, this is so tiny. Jeff, let me try that again. Give myself some more room. So this is 0.3936. And now if I look up 1.7, I'll see what the hell this top one is. And then I just have to subtract those two to get the area in the middle. So what do you get when you look up 1.7?
0.9554.
Let me see, 9554, that sounds about right. That sounds exactly right. Good, sweet, sweet. 9554. So now to find the answer, I'll do 0.9554 because that's too much. I'll subtract off how much it is too much, and I'll get the answer. Yay! So a lot of this makes physical sense if you let it. That's why I like calling standard deviation steps, because so often that visual makes sense. It's how I'm stepping around. Just don't say step when you're trying to define something for me on a test. Don't say step, say standard deviation. So be careful. And whatever the hell that is, I have no idea. What is that? 5618. Did I do that right? Is that okay? Good. I don't know if I could trust my brain. All right. Any questions from that? That's your classic Z-score problem. They give you a mean, they give you standard deviation, and they ask a question. What's the probability is less than this or more than this or between these things? All right. So you make Z-scores, you look up the areas, blah, blah, blah. Part B is that turned on its head, right? Part B, why did I just put a G there? I have no idea. What's up, G? No, stop. So how do I draw this? Stop. How do I draw that 95th percentile? Where would that be?
To the right of the mean.
Yeah, it's going to be way up here. 95th percentile is going to be way the hell up here. 95% below it. So what people do is they'll write 0.95 and then they'll look it up as if it is a Z-score. That is not a Z-score, right? That's a percentage. You have to figure out what the Z-score is. So again, if I want to do that, I got to look up 0.95. Now, what happens when you try to look up 0.95? I think this is the first time, maybe the second time this has happened to us.
The closest is 0.9505.
Actually, do you see how these are exactly the same distance apart?
True.
Do you see the little asterisks? There's supposed to be a line, and of course the formatting got all freaked out. But if you follow that down, do you see how this one would be 1.64 and this one would be 1.65? Since it's right in between, it's 1.645. So you can see it happens in other places. It happens more than these two places, but these are very often used Z-scores. I really want you guys to understand. So it's not, since they're both the same distance, that's the one time you should definitely split the difference. Right between 1.64 and 1.65 is 1.645. Right in the middle. Maybe? What's in the middle of 4 and 5? 4.5. So what's in the middle of 164 and 165? 1645. So that's why the Z-score is 1645. So coming back to this, can we make that into an X score now, a rent? Yes, we got our little formula. Sorry, part C. Where'd it go? Whatever the hell that is. Let's see. Do I really want to do that in my head? $210. I don't know. It's like 1170 something. 1160 something. I don't know. I could be off. Nobody's going to help me.
It's 1192.06.
Thank you. So if you live in this area of New Zealand and you pay this much in rent for a 3-bedroom place, you're in the 95th percentile of rent payers. Okay, I like it. And then of course this last one should be a nice one, right? It's got the least amount of stuff going on. I want to know probably X is greater than 1600. Now no, Jeff, what's going to be interesting about this problem is the answer. The work is going to be pretty simple, I hope. Here's 1200. Or no, I guess not. I guess it's not what I thought it was. No, Jeff, 1600. I don't know where the hell 1200 came from. You crazy, crazy fool. You foolish person. Okay. So if I make that into a z-score, you might see immediately what the freakiness is. I mean, 1600 is going to be pretty damn far away. I think it's 4 point something, 4 point, I don't know. Anybody get that yet?
I got 4.62.
I don't know. I'm hoping that most of you guys are to the point where that is obviously way far away, right? Where does unusual start? How many steps up and down?
2.
2.
2. How many steps up is this amount? 4.62. This would be like running into somebody who's 9 foot tall, right? You ain't going to do that because holy shit, right? But if you did, that would be a day to write down in your diary and hope that your camera battery is working because you're going to want to record this 9 foot tall person. Maybe you're running. I don't know what's happening. They've been irradiated. I don't know. Anyway, sorry. Does your chart even go up that far?
No, it doesn't.
No, it doesn't. So what the shit? So here's where I disagree with the chart. Notice what the chart says. It kind of gives up. See, 3.5 and up. Oh, yeah, I know. So this works right at 3.5. But when you get up to 4.6, this is more like 0.999937 or whatever, right? So here's what I will do. Here's the answer from the chart, right? Where did I go? Here I am. The answer from the chart says, this is 0.999. So what's my answer? Is that cool? Because we looked up the z-score in the chart. We got 0.9. That's below. That area is below. So what area is going to answer? Because I want greater than.
0.0001.
Yeah, so I'll accept that. A better answer would be about 0%. So if it's off the chart, you could answer about 100% or about 0%, or you could use the 0.001 or the 0.999 like the chart says is fine. All right, maybe. Now, I tell you what, I really want to have some part of today. I want to let us out here early too. Do you see how these are the same questions really? I just have a different mean because now we're in San Diego. So of course the mean went insane and standard deviation, right? You guys with me? Nothing new down here really. So if you want to try these out on your own, we can go over them. I kind of want to get into chapter 7 a little bit before I let you out of here. You guys with me? So all the questions in number 2 are pretty much exactly the same as number 1, right? They just have a different mean and a different standard deviation. Okay.
Well, we have a quiz for chapter 6.
Yes. Here. Actually, I think I have it mislabeled, but I have it on the right date. Let me show you. I think I say 5 and 6. It's just on 6. Oh no, 6 and 7. That's better. I like it. So we do have a quiz on 6 and 7 in April 12th after spring break into April. Yeah. Yep. Okay. Now, we're gonna get into chapter 7 a little bit. We're gonna talk about the idea behind chapter 7. And then I think on Wednesday we'll have a very concrete example illustrating what we talk about today. But here's the idea. If, in fact, here, let me pull this back up, the sheet we were just working on. Every problem we've done in chapter 6 so far, if you've noticed, these problems, how many places, how many 3-bedroom places did I pick in part A? Do you understand what I'm saying? What's the probability that how many are picked? 1, right? One. Every problem we've done so far, if you look back at it, what's the probability that we pick one person and they're this? What's the probability that one person's pregnancy lasted this long? If you've done that part of the homework, it's kind of sad, but it's okay, right? Evidence of cheating. Sorry. So chapter 6 is all about laying the groundwork of what a z-score means, how it leads to percentage, all this stuff. And to do that, we pick one thing because it makes everything easier if I just think about one person or one thing picked. Chapter 7 says, we know better than that shit. What do we do in statistics? What's the main thing we do in statistics? Get everything started if I'm going to do an analysis. I go out and I take a breath. No, we go out and I take a walk.
Collect data?
No.
Oh,
Yes. Take what?
collect data?
Collect data from a sample. There it is. Okay. You're like, dude, you suck at charades. I know. Sounds like ample. I know. All right. That's not how you play. You're not supposed to talk. So chapter 7 says, that's great, chapter 6. But let's talk about what we actually frickin' do. So chapter 7 is going to ask a question like, what's the probability I take a random group of 7 people and their average height is more than 6 foot tall? You guys with me? Chapter 6 would ask, what's the probability that one person that you pick randomly is taller than 6 foot, right? Chapter 7 is going to say, what's the probability you take a random selection of 7 people and they're taller and their average height is more than 6 foot? Do you guys see the difference there? So let me ask you this. If you went out, holy shit, sorry. I came way too close. If you went out and you like randomly picked a person and they were taller than 6 feet, would you freak out? Would that be like you'd call your mom or something? Or you write it down in your diary? No. You with me? That's not that amazing. What if you picked 20 people, just randomly picked 20 people, and their average height was more than 6 foot tall? Would that freak you out? I love you guys so much. Yes, it should freak you out, right? You should stop and go, what is happening today? Where am I at? Right? Maybe? No? A little.
Will feel
Okay.
really, really short.
Yeah, well, I could go the other way. All right. Well, what if you took a random sample of high temperatures in San Diego? You take one day last year and the high was 70. Would that freak you out? No. What if you took one day last year and the high was 96? That's a little bit wow, but would that like freak you out? No. What if you took 80 days and the average was 80? It was what did I say, 96? No. No, that would freak me the hell out, right? So the idea is a group cannot get as far away from the mean as often as an individual can, right? So if I graded the test and one person got a 30, I'm like, oh man, but I'm not going to freak out about it. If I grade the test and a random sample of 30 people got a 30, is that going to freak me out? Is that going to freak you out? Especially if you're in that group, yes. Right? Then I'm worried. Then I'm like, what the hell did I do? Did I make this too hard? Do I make any sense? What's going on? You guys kind of with me? So it's no, a little bit, little tiny bit. All right, so let's build this up. So today is going to be concept, and you're going to love it. Oh, you're going to eat it up. It's concept. It's not even going to be related to the work you're going to do necessarily. It's related to the idea behind the work you're going to do. And if you don't want it, it's too damn bad. I'm going to give it to you. So we're going to go to alternate universe, Florida, right? Everybody ready? Right. I got my portal gun. I'm done with University 137. I want to go to Florida and drop Jerry off on the way in a different universe.
I don't know if you're writing on your whiteboard, but we can't see it.
Don't worry, I'm not. Am I sharing still? Is that what it is?
Yeah.
I was just erasing. Nothing amazing happening yet. Nothing amazing ever happens. Oh, be quiet. So if I go to alternate universe, Florida, and I ask people, I ask individuals, how old are you? How old are you? How old are you? Right? And let's pretend like I'm looking at their IDs or something. Somehow I have this authority, right? So I'm really getting real ages instead of somebody going, I'm 29. No, you're not. Right. You've been pushing 29 for a while. Now, if I graph their answers, here's what happens in alternate universe, Florida. So I ask everybody, there's a ton of people. So I get this. Okay, what the shit does this mean? So this could mean anywhere from 0 to 35, and then let's say here, and then let's say here, 55 up to 100. All right. It's not a good scale, but oh well. So what just happened? What just kind of happened in Florida for who knows why? There's nobody between 35 and 55, right? You guys with me? So I asked, now how did I create this picture? I went to somebody and I said, how old are you? And they said, I'm 87. Okay, you're 87. Put your dot. Then I went to somebody else, how old are you? And they're like, I'm 2. All right, put 2, bam. And then I kept asking, and it just piled up and piled up. So what was the most common ages was whatever the hell this age is here. You guys with me? So it's sort of like a histogram, but with a lot of rectangles, right? Because I had a lot of people. Okay, maybe. You guys all with me? So there's nobody in here. There's a few people that are just over 55. There's a few people who were just born. And then there's a ton of people that are like maybe 18 or something. Maybe. You guys with me? I love it. You're all like, just keep going. All right. Now, so the mean is 45. What if instead of asking one person at a time, what if I ask a groups of size what do you want to say, Jeff? 10, sure, why not? What if I took a group of 10, a randomly selected group of 10 people, and I said, let's figure out your average age. So before I plot anything, so like this dot right there, that's one person, right? That is an individual. Holy shit, how do you spell the word individual? Individual, there it is. That's aged maybe 30, I don't know, age 30. All right. So every dot on this is an individual person. Now, when I make this picture, it's every dot I plot is going to represent a group of 10 people. All right. And by the way, all the problems we did in chapter 6, when you graph a normal curve, that was one person, one thing, one thing, one thing. Every dot on there represented one thing. And that's why you can say, what's the probability that somebody is in here? Well, that's the area of there, because that's how many people are up there. That kind of makes sense. Okay. And you're like, why didn't you say that before? I'm like, shit, I don't know. All right. So now tell me this. We don't know exactly what this shape is going to be, but can somebody tell me what's the most likely thing to happen? Let me help you out a little bit. Is it likely that I'm going to pick these people here? Is that I just randomly from everybody, I just happen to pick those people? Is that likely? Is that likely?
No.
What's the most likely thing to happen? That I pick people that are from
The something that's between both of them, they 68% between both those groups.
Stop. What percentage is in here? What percentage of people are in here?
10.
No, I love you guys. Is there anybody in here?
No.
No, there's not a soul in here. So this is not normal. So be
No,
careful.
but what I meant
68.
is the between 0 to 35 and 55 to 100.
Okay.
I think it's going to be like 68% of like both those groups separately, like 68 of percent
All right.
of.
Stop trying to bring 68 to this, because 68 is not going to come into this. Trust me, at all.
Okay.
Nothing up here is normally distributed. Nothing. Not yet. Anyway, it will be. But here, let me just break it down. The most likely thing is just people from both groups, right? Just a mixture. Isn't that do you guys agree that if I just randomly pick 10 people, shouldn't I get a mixture of both kind of groups, the older and the younger group?
Yes.
Right? It's much more likely than just getting a bunch of people right here. All right, so stay with me. This is interesting. So if the most likely thing is a mixture of people from both groups, shouldn't the average become the highest peak down here? Right? Let me ask you this. Okay, stay with me. You're like, dude, man, today is rough. I know. There's an average age in this class right now, correct? Of people who are logged in, correct? There just is. There's a number. If I take one person, do they have to be close to that average age?
No.
No. If I randomly select 12 people, isn't it much more likely that they are going to be closer to the actual average? I really want this to make all the sense in the world, right? The larger of a sample I take, the closer that sample's average should be to the whole population average, right? The more I take, the less likely it is I just happen to take young people or happen to take old people. I should take a mixture of old and young when I'm taking a larger and larger sample. The most likely average age I'm going to get is the actual average of the whole thing. All right. So what's going to happen is this picture is going to have a peak in the middle and probably a little peak there and a little peak there because of those two peaks. Now remember, is any individual 45 years old in this alternate universe Florida? Is any individual 45?
Maybe. No.
Look at my, no. I talked to everybody. I left nobody out. I hunted them all down. Sorry. I feel like I'm Terminator. But nobody was in between 35 and 50. So what the shit is this peak all about? Well, these don't represent individuals. They represent groups of size 10. Yes. If I get a group of people who are, you can do it, Jeff. Yeah. If I get a group who are 25 and a group who are 65, wouldn't their average be 45? Yes.
Yes.
Yes. So I could, the most likely average age of the people I pick should be around 45. That's why there's a nice peak around 45. Now let me ask you this. Let's see who remembers what's happening here with standard deviation. Whatever this standard deviation is, there is a standard deviation up here. Should the standard deviation here be bigger or smaller? Let me call this sigma 1, and let me call this sigma 10. Right, for one person versus 10 people. Which standard deviation is smaller? Sigma 1 or sigma 10? Which one is smaller?
Sigma 10?
Yes, why?
Because there's more in the total of the deviation.
There's more than what now?
There's more in like being counted together into groups.
But there's more in near the mean. Remember, because standard deviation is about how far away data points are from the mean on average. So doesn't this one stay closer to its mean more often? So this standard deviation is smaller than this one. So whatever the standard deviation is for individuals, the minute I take groups of size whatever, that standard deviation is going to get smaller. And now watch. Now again, there's no proof here. I just want this to kind of make some conceptual sense. The minute I get to above 30, so let's say 31, here's what this picture is going to look like. The minute I get to greater than 30, let me just put greater than 30. This image is going to look like that. It's going to be really, really hard to get just 30 people that are there or just 30 people that are there. It's going to have to be some kind of a mixture that happens most often. So most often you're going to get people close to the mean, and it's going to be very unlikely to get a group of just 100-year-olds or a group of just 10-year-olds or something. So I've obviously kind of made this very apparent, but which thing looks most normal is this one. And here's the magic thing. All right. When am I allowed to use a z-score chart? What has to be true for me to use a z-score chart? The problem I'm working with must be what? When am I allowed to use a z-score chart? It has to be what kind of problem?
A standard normal distribution.
Normal. It's got to be normally distributed. So is this normally distributed?
No.
No. Is this normally distributed? No. It's better, but it's still not normal. Holy crap. It looks like some poor man's Batman signal. Is this normally distributed? Yes. And again, I know it's just me drawing shit, but they actually have proven that for almost every initial distribution, I don't care what the shit it looks like, when you take a group of more than 30, your resultant curve becomes normal enough. Let me put down here enough. I like to say normal enough. Enough for what, Jeff? Enough to use the chart that has all the answers on it, right? If I was in a class and there was a chart that had all the answers on it, I'm like, when am I allowed to use that damn thing, right? So in these cases, if I'm taking samples, it doesn't matter if the original is normal or not. The minute I take a sample greater than 30, I know that my means will become normal. So remember, what does this dot right there mean? What does that dot represent?
An individual.
No, careful. No. These are individuals. These are groups. These are samples, right? So here's the individuals. They just happen to be this old. There's the 33-year-old. There's another 33, or there's another 33-year-old. There's a 66-year-old. There's a 100-year-old. All right. Then I took 10 people. So this group would be a group whose average was 45. Here's a group whose average was 55. This is a group of more than 30. So that's a group that had about a 54 average, whatever the hell, right? So these are groups of people. Yeah, I know. I really, really want you to understand it. These are individuals. That's why this is basically chapter 6 dealt with individuals. You pick one person, what's the probability they're in there? This will be used for a problem that says, if you take a sample of 80, what's the probability that they're out here or something? Okay, so what? I know. Okay, so what we're going to do, we're not going to do this today. I think I'm going to let us out a little early. What we're going to do on Wednesday is I've got a very concrete example of this weird stack of potato looking shit I've got up here, right? I've got a very concrete example that unfortunately most of you will dislike anyway, but I try, right? We'll do it on Wednesday, and then we'll get into actual, what the hell does this mean for the work I've got to do, Jeff? We'll get into that on Wednesday, because this is all concept. You're not going to draw stacks of potatoes. This is just the idea behind what we're going to do, right? Very unsatisfactory. I know, it's too bad, because that's it for today. So next time we'll look at more concrete, what's going to happen, what's the problem's going to look like. Believe it or not, they're going to be almost the same as chapter 6. It's almost too good to believe after all that shit. Okay, so Wednesday we'll go over that handout. We'll go over examples of what problems will look like. I like it. So that's enough for today, I think. All right, what do you guys think? Yes. So let me know if you have any questions. Otherwise, you are free to escape from me.
More of a guess. Were we replacing anything on the formula when we were doing this type of normal distribution?
One thing, in fact, I already told you the thing that's going to change.
Is that n?
No. I mean, n has got to be given to me, but what's going to change based on that is the standard deviation.
Oh, okay.
There's going to be a formula that tells you how the standard deviation changes based on how big your sample is. And then the rest of the work stays the same. You just use the new standard deviation instead of the old standard deviation. It's crazy. We do all the same stuff we did in chapter 6 with the new standard deviation. Too good to believe almost. Okay. You guys, everybody else okay out there? I'm going to head out if I don't see any questions. Okay.
I have a question.
Oh, yes.
Sorry, I know it's last minute, but I was waiting until the last person finished their question.
Sure.
And just a recap, I know you already went over a few of these already, but I forgot what you said for them. For the, it's like a homework question, sorry. For 6.1, question number 14, you said that, I forgot what you said, if it was like left or right, what you had to do. I know you went over it earlier, but I forgot.
So for a z-score distribution, do you remember what the mean is always going to be? What do we always put right in the middle for z-scores?
The mean or
Yeah. What do we always put right in the middle for z-scores for the mean?
for the mean? 0.
0. I like it. So if it's to the left of the mean, will it be positive or negative?
Negative.
There, that's all that means. Left means negative,
Oh,
right means
okay.
positive. Yep. So z-score sign just tells you if you're below or above average.
Okay.
Yeah.
Hey, thank you.
Sure, you're welcome. I'm all alone. It's just me. Okay, I'm there.